Class methods in Python seem simple until you try to register them with FastMCP. And suddenly, you're stuck choosing between decorator order and silent failures. You'll see the cleanest way to expose class methods as AI-callable tools without fighting decorator precedence or breaking your existing class structure. The pattern avoids both the silent misbehavior and the explicit errors, giving you predictable registration every time.
From FastMCP, import FastMCP. MCP equals FastMCP. Class myClass. At class method. Def from string, CLS_S. Return CLS_S. Hash register the class method after the class is defined. MCP, tool myClass from string.
This demonstrates the late binding registration pattern for integrating class methods with external systems. The key concept is separating method definition from registration time, allowing proper binding of self or CLS parameters before exposing the method. What makes this distinctive is that it resolves Python's method binding mechanics with FastMCP's decorator system, which expects standalone functions rather than unbound methods. The approach works by leveraging Python's method binding behavior after class definition. For instance methods, you create an object first to get a bound method where self is already resolved. For class methods, you register after class creation when CLS is properly bound. This maintains clean separation between your class design and the registration logic, while ensuring the framework only sees callable functions with the correct parameter signatures. This pattern matters because it bridges object-oriented design with procedural registration systems. It solves the common problem of framework decorators breaking method binding, while avoiding the anti-pattern of mixing registration logic into class definitions. Use this when you need to expose class methods to external systems like RPC frameworks or AI tooling, while keeping your class implementations clean and framework agnostic. Let's break it down line by line.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for creating AI-callable tools. It bridges Python functions to AI models, enabling tool registration and execution.
MCP equals FastMCP.
Instantiates the FastMCP core controller. This central object manages tool registration, AI model interactions, and handles the RPC layer between Python and the MCP server. All tool exposure and execution flows through this instance.
Class myClass.
Defines a new class called myClass, establishing a namespace for related methods and attributes. This serves as the container for the class method we'll register with FastMCP, enabling tool-like behavior through its methods.
At class method. Def from string, CLS_S.
This defines a class method factory pattern. The @class method decorator makes from string callable on the class itself, not instances, enabling alternative constructors. This pattern is common for parsing or deserialization methods that create objects from raw data.
Return CLS_S.
This instantiates the class using the provided string argument. The CLS parameter ensures we create an instance of the correct class, even when inherited, maintaining proper polymorphism in the factory pattern.
Hash register the class method after the class is defined. MCP, tool myClass from string.
This registers myClass from string as an AI-callable tool after class definition. FastMCP requires explicit registration, and this pattern ensures the class method is available to AI models while maintaining clean class definition separation. The registration happens post-definition because Python's class decorator syntax can't directly target class methods. Class method registration pattern. The class method decorator creates bound methods that automatically handle class references, while FastMCP's registration system intelligently hides implementation details from the LLM's parameter schema. Decorator order matters critically applying at MCP. Tool before at class method will fail silently or raise errors depending on the sequence. Always register class methods after class definition using the direct registration pattern for reliable behavior.
The class method that forgets its class becomes universal.